Jai Hind to all. My name is Aarti Chaudhary, and today we are giving a lecture on network model that is used in our computer networks. So, what the use of this network model, why it is evolved into a computer network model. So, we have to go through that. First, we have to make sure that why we are using it, making a mention this. Next, what is a layered task? For example, we are seeing in our daily life that we are communicating with each other. So by what we use into a postal mail is that what things we are using at the sender side also and the receiver side also, how we can communicate with each other, what are the services we are providing to each other. So these are the layered tasks. So why we are using that network model into it? What's the need of it? So first we have to consider a communication between a two friends, that A and B communication, and they are sending a letter to each other. So these letters are simple, which are has been posted to each other. So we will see that. So first we are having a sender, and now we are having a receiver, and that sender has to send a letter to a receiver, and this. So first we are having a high layers, middle layer, and lower layer. So first we have to write a letter. So any person that is sender have to write a letter to a receiver. So what we have to do is the sender has to write a letter and then put that into a envelope and then have to carry to a nearest mailbox there. Then the middle layer would, then the middle person will come to the post office person will come, and then after it will carry that letter from a mailbox to a post office, nearest post office will there. Then what we have to there is delivery of that letter to a post office which is near. For example, the sender is in Ghaziabad and the receiver is in maybe in Bangalore. So we have to go for our nearest, that is the nearest post office in a Ghaziabad, and then after the post office that is situated into a Ghaziabad will deliver a letter to a carrier. So there is a one person that is a carrier. So there was three important person into a task, that is our sender, the carrier, and the receiver we are having it. So that is the parcel person that is carried the letter from the source to destination is by using a roadside, by trucks or by air. They are for going to a Bangalore, they have to communicate by a flight. So that flight, the carrier is to be carrying a parcel to a nearest post office. So that post office is in Bangalore, because the receiver is in Bangalore. That has to be a carrier giving that letter to a post office. Then post office is to be, then it's a mailbox, their nearest mailbox to a receiver, and then after receiver, the dispatcher will take up and pick from that mailbox, and then after read it the destination address, and then send it to the receiver. This is a layered task which we are using in daily life. So when we have to transfer any data from into a you can say network, computer network, how can we do it? So that is here the layered structure, the network model come to evaluation, that we are using sending a message to that has to be used into a layered structure. So there we having a OSI model. First one model is OSI model. In 1947, the standard is International Standard Organization, ISO. This is a multinational organization which is used for the standards and all. So in that it will making a 1970s, they are making a model, that is OSI model, that is open system interconnection, that is evolved when we have to communicate into a computer network. We have to use that OSI model, that is a reference model which is introduced into in 1970s. So next we are having a, though OSI is an organization and ISO is an organization, OSI is a model which is used into a computer network. There are other models also, TCP/IP model, which is recently used. They are having a 4 or 5 layer structure, but in the reference model, OSI model, this is a 7 layer structure. So we will come a layer. We are having a first layer is a physical layer, which are coming from this. First, second layer is data link layer. Next is third layer is a network layer. Fourth is a transport layer. Then we are a session layer, presentation and application. Then when we have to be any data has to be sent from the sender side to receiver side. What we have to do is we have to send our data with the additional information. So the topmost, this is, you can say, is a topmost layer of topmost, you can upper. This is a lower layer. So this is a lower layer and this is a topmost layer which we are using to measure. So this is a order by which we are using our 7-layer structure into a OSI model. So we will go for one by one every layer and what are the responsibilities of every layer we have to go through, and what the advantage of using when we coming the data from the mention. Because of the topmost layer, we heard the sender will have a packet, and then after packet will come from that application layer and then coming to our physical layer that they are. So this is a interconnection between the layers of OSI model. We are having a their physical layer, and this is a source, this is a source, the sender, and this is a receiver which we are having. So why we are saying that it is up to a network layer? This is the reason why there was this is a maybe you will say a sender, and this is a receiver. This. So we have to send a message from the region. We are having an IP address of any address of, we can say, is IP address and their IP address. If we want to send any letter from A to B, we have to be address of it, because in the earlier example also we are having a letter. On that we have a sender address also and receiver address also. So we are having a sender address and receiver address. What we have to do is that letter, the data has to come from the application layer, that is the topmost layer. That data has to be communicated to then a presentation layer. Then it is so these are the interfaces of this layers. So layer 7 have an interface with the 6, 6 have an interface with the 5, 5 has an interface with 4, 4 with the 3, and 3, 2, and 2 with the 1. And then after there is a communication between them. So all these are the intermediate modes. We are not there is no direct connection. If I am sending a message from Ghaziabad and then there is a sending a message to Bangalore, then there is no direct connection to it. They are intermediate modes. How can we communicate with them? So if we are having a interconnection to a layered procedure, what we have to do is their data has to be coming from the topmost layer to the physical layer, and then after, if the intermediate mode, we have to go up to a physical data link and network, not above that, because that is not acceptable. Because in the network layer we are having a IP address. When we are sending this IP address, something like 128.0.0.1, that is the address, IP address for, and we have to send it to 254 through 34.1.1.1. This is the IP address of destination. So what we have to do is, so that we will check it, the sender is sending in destination, then after it is checking at every intermediate node. It will coming from the sender side, and then after at the physical layer, at the network layer, it is checking if it's the IP address. Then after it will go upside. It will go on the upside interfaces, upside layers. Otherwise, it will forward it to the second node. If it is there, it will check the IP address, and then if our IP address is matched with the destination IP address, then after what we have to do is that that is forwarded. If it's not matching, it will forward it. Then after at the destination type, what it has to is the destination address is matched, the IP is matched. Then after it will go into the upper layers, that is transport layer, session layer, presentation layer, and the application layer. So these are the layers, these are the interaction between the layers of the OSI model, and which we use it. So on the detailing of every layer, we will go through in next slides of it. Next, what we is having a exchange using a OSI model. I have said it ki the data has to be there on from a transport layer. This is application, sorry, it's application layer. So in application layer, the data, what we have to send it, any email we have to send it, any file have to send it, any video, audio, you have to send it. The data is to be there into a sender side. Then after every layer have to add some of the header. So these are the headers. So this is a header 7 which is added on the application layer. At the layer 6, that is a presentation layer, what we have to is, we are adding so this becomes a data of the 6th layer. This becomes a data for the 5th layer. This becomes a data for the 4th layer. This becomes a data for the third layer, this third layer. This become a data for the 2nd layer, and this become, and we are added on the data link layer. Data link layer, we are having adding a tailor also. The tailor is that this is a end of my frame into it, and then after we are having zeros and one, because data has to be transferred into zeros and one, and we are having a transmission media, and at the end we will get into a destination. We are having a physical layer. Then on the upper side, when we go to down, up to down, we are adding. So we are adding, what we are adding is headers into it. But at the when we're going from lower to higher, we are removing. So we are removing headers from. Yeah, we are removing headers from. So from here to here, we are removing this header. From here to here, we are removing this header. We are giving our data back to the upper layer. Then this is, we are removing this, and then we are giving it to the upper layer. Then we are removing it, we have to go to a upper layer. Then if we are removing it, we are going to a upper layer. If we are removing it, we are going to upper layer. At the end, at the destination side, at the application side, we will get our data back from them. So this is an exchange of the data from applications to data physical layer at the sender side also, and same here on the physical to the application layer by getting back to my data which is used to me at that time. So in the layered, we are having many 7 layers of it. So we will discuss all these layers: physical, data link, network, transport, session, and presentation and application layers, which is a layer by layer here. So first of all, we are having a physical layer. So we are data is coming from the data link layer, and then after we are having a physical layer. So physical layers, you are having mainly dealing with zeros and ones here, because the data has to be sent into a zeros and ones. Then after there is a transmission media, and transmission media we are having a receive at the end, that is destination, and we are getting our data back, and then after we are removing the headers here. So as a destination side, we are removing the headers, and in the sender side, we are adding the headers. So we are giving it to the data link layer here. So here the transmission media, they will stop going it. Transmission media has to be wired or unwired. So wired also, we are having wired also, and we are having two things, we are in wireless also. So we are wired also, coaxial cables, we are having a fiber cables, twisted UTPs, and all these types of wired connection. And wireless, we are radio, electromagnetic, we are using that. So these are the transmission media. We will having a 2 transmission media, wired and unwired. This is the physical layer is responsible for the movement from one hop to another. One hop matlab we are having a one node, and then after delivered to the next node. These are also including the nodes which are the intermediates, which are the intermediate nodes, that the interaction between the intermediate nodes. So we are having a interaction between the intermediate nodes. So we are delivery from hop to hop. That is one node to another node, we are having a delivery of it. Next, what are the responsibilities of physical layer? When we are learning the physical layer, the first and foremost is the physical characteristic of media and interface and medium. What is the, we are going for a computer network. There was many of the computers are connected with each other. There is a network of computers with it. So what are the interfaces of that devices? What are the end devices we are using? Any switch we are using, any hub you are using, any gateway you are using, any router you are using. So that is a interface between the transmission media, that is a transmission media, and the device, end device we are using. It is there mentioned that we are having different types of transmission media also, wired and unwired also. Next of the responsibility of the physical layer is the representation of the bits. The bits have to be represented as a continuous zeros and ones. As we know that we are sending our data into analog also and digital also. The data has to be transmitted between as a signal also, as an analog also, by a electric and an optic. So what we have to in digital also encoding, we are using it zeros and one, continuous zeros and ones, or if we are using an analog here, so what we have to do is making a high and low we are making, and then after we are transmitting our data from one source to destination. The third responsibility of physical layer is a data rate. Data rate, what is the data rate? The data is transferred rate which is transferred from the sender side to the receiver side, that the rate, the number of bits, the 10 bits per second, yeah, 20 bits per second, what we have in the real life, what we have, 10 Mbps, 10 Mbps, matlab 10 MB of bits per second is moving from source to destination. So these are the rate, number of bits sends, data has been sent from sender to receiver at the physical layer, that is the foremost. Next is synchronization of bits. Synchronization is when we are sending a data from a sender side and the rate is not similar with the receiver side. So we are sending a data, and then after this is not a synchronization between them. They are not synchronized according to a clock also. So the data has to be lost. So what we have to be, the foremost is to be at the physical layer, you have to be synchronized. That has to be, the clocks of the sender receiver have to be, must to be synchronized into each other. So having a same data rate, if it's less than or greater than, then we have a loss of packet, yeah, duplicacy of packet, yeah, delay of the packets will be the resulting of that. So that is not to be acceptable into a computer network if we want to send a data. If one data is missing, then the entire message will be from an application will be a useless message for us. That is also because we are not getting the full information into it. Okay. Next is the line configuration. The fifth one is the line configuration. The physical layer is concerned with the devices, connection of devices, which is a point-to-point, one-to-one communication, and multi-point. There was many other devices which are connected. So that communication has to be, you have to define it the physical layer, that is point-to-point, one-to-one. You are going for peer-to-peer. Otherwise, it's a multi-point. We have to wear many points according to that. Next is the sixth point is physical topology. As physical topology is what are the devices are connected, what are the topology, how they are connected to each other. For example, if we take a star topology, we are having a central device and which is coordinating between the other network of the venture. There was this is a device and then other are mentioned. So it is connected to a star one. Okay. Next, what we are having a bus topology. We have a common line, and then after the devices are connected to each other. So these are the devices connected to each other. This is a bus topology we are using. In a common, there was a common line, and then you using other topologies also. We are having a mesh. Mesh is that if if there was 3 1, so then all are connected to each other. There was a mesh. This is having a most complexity, more complexity, because every device is connected to each other. There was star also, bus also, ring also. There was so every the topology has to be defined into at a physical level, that how the computers are connected to each other. So they were also hybrid also topology. In a hybrid topology, this is a combination of 2 or more topology which we are having. Next is transmission mode. Transmission mode is how we are sending a data, transmitting data from the sender to receiver. That is to be simplex also, half duplex also, full duplex. Half duplex. If this is I'm saying that simplex, this is a receiver and sender, this is a receiver. We have sustained that this is sending the data and this is receiving the data only. We can't make it interchangeable. Changing of it. This is, for example, broadcast, when we are seeing a TV, we are only seeing the TV. We can't take it can't take a input from us. So that is also broadcasting one way. That is a sender bus sending information, receiver is also receiving the information. Next is half duplex. In this, at the same one time, the sender is sending the data. At the other time, the receiver can also send the data to sender, but at the one time, one operation will be happen. that is there. This is an example of walkie-talkie also. Walkie-talkie, at the one time you are saying, communicating, and the other one is listening, and at the time agar if you want to send some information from a receiver to sender, it will send it, and then after the sender will listen to it. So this is an example of half duplex. And the full duplex is, at the time you are sending information, you can also receive it, like at the telephone, when we communicating on our phone, then after we will listen to also, and we will give them our stuff also, we will say something, we will mention. So this is a duplex communication, that is two-way communication. We can listen also, and we can also send making things to the way. Next layer is data link layer. In the data link layer, the data is coming from the network layer, and then network layer we are having a data which is coming from that, and then after we are adding a headers also. So at every layer we are having a headers, that is additional information that is coming from the data is coming from the upper layer, then it's going to a lower layer, it have to add some header, and then after in the special thing that is in a data link layer is that the tailor, that is the end of my frame. So in that layer we are having a frames. This is a layer for making a frames. So that frames having a sequence numbers also, and other things also. So we are having a data here in the middle, and we are starting with the headers and end with a tailor. So we are giving data through a physical layer, then we are having a transmission media, and then after physical layer, so we will go it back to a data link layer. Data link layer you are having a tailor also, and this we have to remove it there, and then after we are pass that message to a network layer. So what are the responsibility? So that is also a hop to hop delivery into a data link layer. So these are the responsibilities which are used in our data link layer. The first one is framing. Framing, we have to make a frames. First frame, second frame, we are having a sequence of frames. So we are manageable unit, that is we can transfer. So we will send first frame, then after second frame, then after third frame. That are the frames which we have to send it. Next is the physical addressing. Physical addressing is called MAC addressing. MAC addresses of 6 bytes which we are having. The 6 byte of the MAC address, that is equals to 48 bits. So that has to be fixed. That the layer have been, if we want to send a sender to receiver, the MAC, if we want to send a sender to receiver, the MAC address will be changed, because it is changing from hop to hop, because the delivery of the data link layers from one hop to one node to another node. So that the MAC address is the sender and the intermediate node, and then after MAC address, then it will update it accordingly into a network. So I am saying that physical address, that is a MAC address, which is of 6 bytes, and we have to be that if we go into a network, intermediate nodes, so every time the intermediate node going up to a network layer, and then after checking it is by using a what logical addressing, IP address. If it's not, then it is updating what one, that is a physical address, and that is also called as a MAC address, which we use into our computers. That is also updated. So that is to be added into a data link layer. That is what we are having a flow control. Flow control is that for example, we are having a flow at the sender side is to be like 10 Mbps per second, and at the receiver side it's less than or more than 10. So what we have to do, flow control, something like the data has to be lost, and the data has to be overflow, the data has to be not acknowledged, your data has to be, these are some problems which are having a flow control and all. Duplicacy of data, your retransmission of data, that has to be controlled by a flow control, that is a data link layer work. Next is error control. If we want to send any data to a network, then the data has to be transmitting, though any of the bit may be changed, or if it's changed, then how can we detect it? So these error controls are having, we are having many algorithms of a CRC, we are having the check some all these algorithms which will come to know about that the data is to be detected, that is to be error, having errors, or if it's error then we have to check it, or we will correct it also. So error detection and error correction also methods we are having. So next is we are having a access control. Access control, if two or more devices connect to a same network, so what we have to do is that the data link layer is responsible to control over that dimension. So all the network which are connected to a all the nodes connected to a network, then if they are using a same link, that has to be coordinated between each other. The data has to be coordinated between each other. So the access between all these nodes has to be coordinated and supervised into a data link layer, and there's a control over the devices at any time in a network has to be there. If we want to share any information, then one device is having information, then it is connected to into a network, then after the other also want to communicate, want to take it will take a file from there, because they are connected into a same link, and same link also they are interconnected to each other, forming a network to each other. So this is a responsibility of the data link layer. Next, this is a hop to hop delivery. Doctor, if you want to go end user, this is the end user. If you want to have data link layer, data is transferred from the physical layer, and this is a hop to hop delivery. Then after, in the intermediate node, what you have to do is you will come to a physical layer. This you have to make the header, remove the header of the physical layer. Then after, data is transferred from the data link layer, and then after data link layer, that the data has to be transferred to the network layer. So but here we are just showing to our only the data link layer. If the data is not, if the destination is not reached, we will go for making that header add to it, and then after it will go to other hop. This is this hop intermediate. Then after we will having, this is a link, this is a transmission media, and then after, if it's if destination is no, it's not a destination, then what we have to do is making that packet wrap into a headers and all, and then after transfer into a link, and then after up to when all the data is not reached to a final destination, then after data link, and then after you will go to a application layer to transfer the data to a destination. So this is a hop to hop delivery which is used into a data link layer. Next, this is a network layer. Network layer, we are having a data is coming from the transport layer, and transport layer we are having a data, and then we are having a here headers. So what we have to do, these headers has to be added onto a network layer, and that data has to be sent to a data link layer. So we are adding a headers, then the data is to be a physical layers, and then after transmission media, and then after physical media and data link media, and then after we are having a data into a transport layer, there we are having data, and then after here, this is on a destination side, we are having a removal of these headers, and then after the data is transferred to a transport layer. This is a way where the network layer works. So network layer is this is responsible for delivery of individual packets, because we are having packets here, and these packets have to be a source host to destination host. So this is a host to host delivery of that, because here we are using a IP address, because IP address is not changing from source to destination. MAC address is changing, that is used into a data link layer. So these are the responsibility of network layer. In the network layer, what we are having a logical addressing. In the logical addressing, what the logical addressing is IP address. What we are using a IP version 4 we are having user, that is of 32 bits we are using. So that is of in the 0 to 255 dot, any value 0 to 255 dot 0 to 255, they were any value of this, and 0 to 255 that value is. So any IP, for example, 197.1.10.2. So this is the IP address. Every you can say is every this point with this decimal is connected to a 0 to 255, ranging from 0 to 255, and this is also a which class is it? Is this of B class, C class? So we will distinguish. So this is the IP address. For what in this network layer, what we are sender having a unique IP address. because the IP address to be unique and universal. That is not changeable, and the source and destination address is not changeable. Here have to be. So at the source is adding the address of IP address of the destination. If we want to come into a other network, the IP address is not changing. It will confirming that if the IP address is similar, then it will move to a next node. If IP address is not similar, it will going to a network. So that the IP address is to be maintained as a network layer, and this is including the source and destination address, the receiver address also, and the receiver address is not changed at when we coming into a network, or if we are having an intermediate modes into it, so it's not changing. So the MAC address is updating every time we are coming from hop to hop. The MAC address changing, but not the IP address we are having. So that is done by our routers, which are we having a dynamic or static routers. We will see in the other units that what is the router do, what how it is maintaining it is. So all these things are being the work of the router. Next is routing algorithms. Routing, what we are having is independent network or links are connected to create a intermediate nodes. And so in a large network, what we have to connect, if there was many nodes are connected to a network, and then after we are having an IP address of source and destination. So how can the network knows ki in which path you have to go? That is known by a routing tables. That is a function of routers or switches, which will route from source to destination, and then after destinations of source by using that routing protocols which are having used in a network there. So this is a source to destination delivery of it. If for example we are having an end system here, this is a source and this is a destination we are having here, and that this is called a source to source delivery is to be there into a what we are having a network layer. So in the network we are having a source to destination delivery, and hop to hop delivery is a work of physical and the data link layer. Okay, so next what we have to be, our data is coming from the network layer, that is transport layer, to the network layer. We are adding our net headers there. Then after header is added to a data link layer also. Then after that it is coming from physical layer. We are having a tailor also there. And then after by a what media, transmission media we are having it. Then after we are media, we will having a physical layer, data link layer, and the network layer, where it will, what it is checking. If for example it is having a IP of A1 and it is a IP of having A2. This is IP of having A3 and A4 IPs. For example, these are the IPs. Then after what we as when we giving into a packet, there was source address. Source address is A1, and at the destination address there was a A4. Okay, that is the address of that. So this is a A1, A2, A3, A4. What is to be? It is the packet is having a message of source address and destination address. That is a IP address, and then after network layer, it is a M1, M2, for example M3 and N4. So it is having a source MAC is M1 and the destination MAC is M2, for example, because it is hop to hop delivery. What we is updating we are having a data, and the data is to be transferred to, so this is added to a network layer, this is added to a data link layer. Then after physical layer having a headers, and then after transmission media it will arrived at B. In the B, what we have to check is, okay, fine, the physical layer, we have to remove the header, and then after at the layer, what we have to is the source and destination address, that has to be of, we have to check it. It's M1, M1 or, okay, fine, it is there. But it's A1 or A4? No, it's A1 or A2. That has to be, that's not the destination. Then it's moving from A3, and then it's moving for A4, and then it's moving from this. So this is source to destination delivery, and this is hop to hop delivery we are having. So at the transport layer, we are having a segments here. The data is to be having segments, and then the segments are divided into this. So this is a process to process delivery we are having. In that we have a service point delivery, that is the one point to other point, that is process to process, because we are running many messages, many process into a user terminal. We have to deliver from one process to other process. This is a service point delivery that is to be there. That is how we are having a port address has to be here, so where that post has to be there. Next is segmentation and reassembly. We have to segment the data, that is on the packets we are having a segment sequence number of according to, and then transmit it at the destination. So you have to be assembling of that. Connection control, that is a connection oriented and connection less. The connection oriented, you have to be make a connection, and then after that is reliable. Connection is not a reliable. So this is example of UDP, and this is a TCP IP what we are using here. Flow control, and flow control, you have to be flow control and error control, which is data link work, because it is a process to process. So you have to be assured to the process to process delivery of flow control and error control into it. So next we have a process to process delivery. This is a process to process reliable UDP and TCP. Next is session. We are having a data from coming from a presentation to transport, and then after from this to destination. So this is source and destination. We are synchronized. The work of this is making a dialogue control, and this the dialogue control is the way has to be communication has to be a one way or two way. That is a dialogue control. We are having synchronous. That is we are having adding a checkpoints into it. If we want to say we are having a 2000 page file, and if we at every 100 page we are adding a checkpoints. If we want to add a checkpoint, if so at 100 we are making a checkpoint, 200 we are making, 300 we are making, 400 we are making. So at 500, for example, 523 we have a crash is happening. So we have to send 501 to 504. Other 500, the previous one 500 is because they are sent because we are having a checkpoints. So this is a synchronization. Next we are having a presentation layer. We are coming from address application layer to session, and session to application. We are having adding a header. So this is translation, compression, and we are having encryption. Translation is the data has to be translated. The data has to be in the form of the characters, strings, and so according to the user format, sender format, sender dependent, receiver dependent, the data has to be sent accordingly. So standard dependent and the receiver dependent. Encryption is what we have to encrypt the data at the sender side, also receiver side. If we get a message or make a, so it is due for the hacking purpose. Compression is making a data compressed form, because we are having videos, number of bits will be compressed, reduced by that. So next we are having application, that is the foremost. Either the user interface here, the human interface here. So it is user responsible for the providing a service to a user. So responsibilities, we are having a terminal, that is network terminal, where we have our process from where the data is sent or received. We are sending a file access and management. We are having a file mail, sending a mail, forwarding a mail, storing a mail, and then after repositories of the database servers and all that, file accessing and management of the file on the local computers and all. So this ends my topic. Thank you.